We did 2.
We did 2B yesterday, yeah. So today we'll go through 2C. All right, so this is a skill we've learned before. What we have here is a function of x, it's like the equation of a line, and then we have g of x, another function, which is a quadratic, okay? So we can identify this as a line, y equals mx plus c. We can identify this as a quadratic because the leading power is a 2. So if we're asked to find f of g of x, what that means is we're putting the whole g of x function into f of x. So everywhere there's an x, all right, so maybe just to remember, if we're finding f of 1, we're putting the number 1 everywhere there's an x. If we're finding f of g of x, we're putting the whole function everywhere there's an x. So we're going to put that whole function right there. So we're going to have f of g of x is 2 times 3x take x squared. All right, so 2 times x, and then we have plus 3. Okay, so that's f of g of x. Now we call this a composite function. Composite coming from composed, because we have one function composed of another function. One function made up of another. Now we can simplify this by expanding it and collecting any like terms. Here there are none. Okay, so f of g of x can expand. Okay, let's look at g of f of x. This time, f of x is being eaten by g of x. So you can think, now what we're going to do is we're going to take f of x and we're going to put it into g of x everywhere there's an x. So we have 2 places where we're going to place the whole function f of x. So g of f of x, we take the f of x function, in it goes. So 2x plus 3 is going there, and then 2x plus 3 is going there. And again, we can expand and collect like terms to simplify it, which we will do just to draw out the algebraic skills that you're expected to know. So we'll have here 6x plus 9, take away. And then what I'm going to do here is I'm going to perform a perfect square expansion in one step, right? Remember, if we have a plus b squared, it's a squared plus 2ab plus b squared. So here we're going to have 4x squared, all right? The a term squared. And then we're going to have plus 2ab, and then plus b squared. Now I've put it in brackets because that negative needs to distribute to every term in the brackets. So we'll go through and do that. We have 6x plus 9, take 4x squared. We'll multiply this out. That's going to be 4x times 3. That's going to be take 12x, and then take 9. So we're fully expanded. Now we can collect like terms. We have 9 take 9. We have 6x take 12x. That's going to give us minus 6x. And then take 4x squared.
Do we simplify if we can take 2x out?
Factorise 2? No.
Why does it take 12?
Here? So 2 times 2 times 3 gives you the 12x, and then we have that negative that's distributing to all of those. Yep. Very good. Okay, so in question 1 of this exercise, all you're going to be doing is processing composite functions, simplifying them. And in question 2, we're given a composite function. We're told g of f of x is this equation here. We need to pull out what's g of x and what's f of x such that this is the composite function. Now this is one that sort of takes a bit of intuition, a little bit of insight. And what I'm going to do is I'm going to draw the answer, I'm going to write the answer up here, and then it'll become very apparent to you why that's the case. So here we have g of x is x to the 5, and f of x is 4x take 3. So now you can see if we have g of f of x, what's happening is g of x is gobbling up f of x, it's going to eat it, so we have 4x take 3 in the brackets there to the power of 5. This would be the composite function. All right, over on to B. All right, so basically the interior part is going to be whatever in brackets, whatever in a root All right, so f of x in this circumstance is 5x take 9. And our g of x is 1 on top of the square root x. Okay, we can see that those will compose together to give us that function. So I'll stop there. Let's go straight to 2C.1. I don't want to spend too long on it. So yeah, we shouldn't take long, maybe 10 minutes.